All right, Miss Howard's Chemistry, Unit 8. This is Chemical Reactions, Part 6. And we're still working with a lot of the Texas Essential Knowledge and Skills that deal with calculating and dealing with moles and naming formulas and all that good stuff. So we start on capital letter E, redox. Okay, we're talking about types of chemical reactions, and we're at an oddball type of chemical reaction. It's called a redox, or an oxidation-reduction reaction. So they used the RED from the reduction and ox from the oxidation-reduction reaction. So we say redox. Okay, it's defined as a reaction in which the elements show a change in their oxidation numbers. Do you remember how we talked about those metals that have more than one oxidation number? If it has one of those metals in it, you know it's going to be one of those types, or very possibly could be one of those redox types of reactions. Or if you know a few rules about oxidation numbers, then you can tell a redox reaction when you see one. The problem with redox reactions is that they can be a redox reaction and another type of reaction at the same time. Redox reactions are a lot tougher to balance, and you won't have to balance redox reactions like they're supposed to be balanced unless you take AP Chemistry next year. Lots of reactions, again, can be redox reactions and another type of reaction at the same time. So, oxidation numbers are the key here to these. And when you talk about oxidation numbers, you need to know, again, some basic rules. So if a substance combines with oxygen, it's a redox reaction. That's where they first got the name oxidation reaction, or so it combined with oxygen. They just expanded that. And oxidation numbers of a pure element, like it's pure on its own, we always say it's 0. So if there is a pure element on one side of the yield sign and it's combined with something on the other side, you know it's a redox reaction because its oxidation number had to change from 0 to something else when it was combined with another chemical. The cation, positive, is always written first. That's consistent with everything when you're talking about a formula. And the oxidation numbers in a neutral compound all add up to 0. So if you look at all the oxidation numbers in H2O, when you add them all up, they should equal 0. That's how we know we've written the formula correctly. There are a few more rules that you don't need to worry about just yet. Okay, number 4. Redox reactions are used in batteries. It's huge. That transfer or movement of electrons is actually what the electricity is. So when those electrons are moving from one place to another, we know we've got a redox reaction. That's all we're going to talk about on the redox reactions.